Logistics.
And it's going up. Hey, everybody, welcome back to the Sustainiacs. I am Michael Vincent. I've got a new Sustainiac. Well, he's not a new Sustainiac. He's been a Sustainiac for a while, but he's new to the show. His name's Tim Noonan, and he is the founder and CEO at Evertrak. Correct?
Correct.
You're also a Marine veteran. Thank you for your service, my friend. My father was a Marine.
Well, anybody who had a dad as a Marine is an honorary Marine.
Well, thank you, sir. He was Korean War. He was recon.
Really?
Yeah, and he built our house, and every single room had its own circuit breaker. So if I was grounded for not making my bed to specifications, I was grounded to my room, and I had no power.
Is he still with us? Is your dad still with us?
He is not with us, unfortunately. He is not. But yeah, he was. That's how I grew up. So. How am I going to get up to go to school? I leave for work at 5 a.m., be ready. But school's not there till 7 o'clock. You can wait outside.
Right. That's right.
That's how it was, brother.
Told
But how
my
are you,
kid,
man? What's going on?
Cold builds character.
Yes, it does. Yes, it does.
No, we're in St. Louis where it's cold, which is a great weather for making railroad ties out of recycled plastic and glass fiber. And we are, figuring out how to blow up this wood railroad tie industry because the world's run out of 100-year-old trees to make railroad ties, and we got forests of plastic right outside our door. So we should just use
forests of plastic. I didn't know St. Louis was in a forest of plastics.
The world's in a forest of the ocean's in a forest of plastic.
It really is, and the other. I mean, the wood railroad ties aren't exactly just a nice piece of wood either, right? I mean,
yeah. No, I mean the biggest innovation in wood ties was the fact that they were, hundreds of years old, and the second biggest innovation was the fact that they needed something to do with this, with this tar that came out of burning coal, and they created creosote, and then creosote ended up being a great treater for wood. But for the fact that it causes cancer, and it is still the industry standard to today. The only place you can use creosote in many states is for railroad ties. You can't use it.
So? Okay, so what are they using in the railroad ties for, like, landscaping?
Those probably don't have creosote in them anymore, unless you go buy. Unless you go to, Menards or Home Depot and you can buy
an actual railroad tie.
You can buy an actual railroad tie.
Yeah.
Okay. But they if you're using any kind of sustainable gardening practice or any kind of gardening at all, you wouldn't use a creosote tie. You might use it for
I just wonder how many raised tomato beds there are out there that are made out of actual railroad ties.
Yeah, exactly.
You know what I'm saying? Because it causes cancer, but there's nobody going around the railroad, like chipping off wood and chewing on it or smoking it or anything like that.
No,
right? But it leaches into the water.
It leaches into the groundwater and these big, down, I think it's in Houston. There's a couple cancer clusters that are related to creosote treatment. So any place that they've done this creosote treatment, I mean, it's kind of like PCBs. I mean, it just,
like you mean around an area where they're treating wood with the creosote, and then it leaches into the local groundwater, etc. Yeah. Okay. Yeah. Gotcha. Yeah, that's all right. I see it. So, what are you guys building? Give us a lowdown on Evertrak. How what are you guys doing, and then let's get into why and how and
So there's about the United States railway system, that really sprang up in the mid 1850s. You got to keep in mind that it's so interesting that talk about a government that could do two things at once. During the Civil War, I believe it was the day of the Battle of Antietam Creek. Abraham Lincoln signed the Transcontinental Railroad Act that created the Transcontinental Railroad. And as you know, this was a big deal for the Lincoln administration, which was to connect the East and the West through rail. And you know, they would go and cut down trees and make railroad ties. And railroad ties are the steel sits on a railroad tie, which is made from wood, then sits in typically granite, what's called ballast. And you know, that was the innovation.
That's the gravel. The ballast is
that's the gravel. It's called the ballast.
And that's to be able to give way for hot and cold and try and keep it level at the
same time. It's a big insulator. It's a big foundation. You know, foundation. It's big. It's foundational. You know, it creates a foundation. It allows the tie to sit and not slide with, you know, lateral stability.
Yeah.
But you know, the interesting thing about the railroads in the United States as they've evolved is that they're, you know, mostly for heavy haul freight, which is a lot different than other countries where they're mostly for passenger.
So, yeah, that's one thing people don't really realize is freight doesn't move on rail in like Europe. It mostly
doesn't.
It's truck, and then people move on
people and rivers and canals but in the United States, moves by rail, and you have this installed base of, you know, it's an arguable number. It's, you know, 550 million to 700 million of these wooden railroad ties that are installed.
Is that current right now?
That's current. Yeah, that's currently, you know, 30,000 miles, 300 to 3,200 ties per mile. So there's, you know, hundreds of millions of these wooden railroad ties. And you know, I've never built the model, but you can imagine you have these really dense trees that you know, and then the ties are soaked in creosote and they last a longer time. And even there was, you know, bugs and moistures in the Southeast, but you know, as we run out of these old growth trees and we not using as much creosote and haven't found a chemical or a species that can put up to the wear and tear of the bugs and moisture in the Southeast, you know, there's typically about 18 to 20 million wooden railroad ties replaced every year in North America, about 3.5% of the installed base.
Yeah, I was going to ask what is the percentage that's sitting around waiting to be installed as well? 18 million.
Yeah, you know, my sense is that the inventory numbers are probably half the installed base. You know, but the, you know, so just real quick. So in that 3.5%, there's about a third of that is really high velocity railroad ties that are being replaced 10 to 12% in the southeastern part of the United States. So of that, say 18 million.
Yeah.
So say of the 18 million ties that are replaced every year in North America, 6 million, this high velocity turns are happening around 4 to 6 million in the southeastern part of the United States.
Gotcha. So it's disproportionate.
It's disproportionate. Yeah. And so, you know, our thesis is that, you know, if we could make a railroad tie that was as strong as wood, that had the engineering properties of wood, which is mostly measured in strength and stiffness, so the ability to bend without breaking and then not deform. And then there's some things about thermo expansion that when it gets hot, does it get, you know, wide or narrow? You know, we believe that we could have a new conversation with the railroads around, instead of thinking about a railroad tie as a commodity that, you know, you just buy as many as you can afford, think about it as a different commodity where you buy on total cost of ownership instead of price. Because, you know, once you're, you know, if you, you know, our customer Union Pacific says they believe our tie will last 50 years. if you're talking about something that lasts 50 years versus something that lasts 10, you get 5 ties, but then you got to install it 5 times. And then you got to pay to get rid of a creosote tie. That costs about $10 a tie. You got to pay to get rid of that. And your operations are impacted. So, again, our thesis is that, let's take this affordable, abundant, wide spec plastic that there's not a huge demand signal for. Let's engineer it into a product, and then let's go keep trees from getting cut down.
Unbelievable. And why does it have to be replaced? Why does it only last 50 years? Is it because it breaks down due to just wear and tear?
We don't exactly. We don't know if it, it's a great question. Like, only last 50 years. Like, it's a long enough time frame that, is way beyond anybody's ability to imagine. Right. But who knows if it would last longer? I mean, it'll last longer than the steel. The steel will last 20 to 30.
Is that right? So the plastic railroad tie you're building through engineering means, you study it, you know what the tensile strengths are and the makeup, etc. It's predicted to be 5 times longer than the steel?
No, 5 times longer than wood, but it'll outlast the steel. The steel will wear out before the tie.
That is interesting. That is really interesting. And then both the steel and the tie can then be recycled and repurposed.
That's right. And, unlike wood that you need to handle as a
it's just done
material. Yeah,
it's just done. You can't recycle it into anything.
Can't recycle it.
It deteriorates and falls apart, right? I mean,
and then the railroads have to pay to get rid of that tie. I know that there's one Class 1 railroad in the Southeast that has millions of wooden railroad ties just stacked up on their right of way, figuring out what to do with them. I mean, you got to allocate cars.
Yeah, you can't burn them.
you can't burn them. You got to landfill them. You landfill them. You got to pay exorbitant fees. So every one of those ties costs about $10 to get rid of.
Yeah. So our solution to a carcinogen being buried into earth is just pay money and it'll be okay.
Well, that's right. Yeah, problem solved with money is not a problem.
Probably, just give some money and then it's not a problem anymore. Right? That is completely ridiculous. So what is your background? How did you get into it and why?
Yeah. So, my background, in the very near future or near past is that I retired from Boeing in 2017, and most of what I did at Boeing, my last job at Boeing, which is one of the great, despite everything that's going on, is one of the great companies ever in the history of the world. But my last job at Boeing is I ran our defense training business. So taught people how to fly, fight, and fix our airplanes, and had a couple other programs. But
really?
But mostly what I did at Boeing is commercialized technology. So we started a little ventures business. We had this thesis that inside Boeing, inside any big company, entrepreneurs are everywhere. They just might have landed at a big company, and how do you find them and how do you give them skills? And, there's sort of a deep portfolio of things that we could bring and commercialize at Boeing. So spent a lot of time doing that. And so as I was thinking, I took an early retirement from Boeing, and I had invested in a local plastic recycling business. And as we were staring at that business, we kind of said, well, where can we take the plastic and put it into, a part? How do we make something? And landed on the fact that no one had really fixed this composite tie using recycled plastic for composite ties for a bunch of reasons. That included the innovators kind of listened to their customer and they said, oh, we want something as cheap as wood, but they really need something as strong as wood. They lost lock on manufacturing quality. They lost lock on supply chain quality. So we built a tie, and our goal was to make it as strong as wood, not as cheap as wood. If it was as strong as wood, it's going to be more expensive. So it's another value proposition, and there's just a really long testing cycle. I mean, we kind of needed to test for years, 3 to 5 years, to really get the confidence of our class 1 customer.
Yeah, you've got a rather large piece of machinery flying down a rail, and you don't need the track or the tie to fail.
Yeah, that's right. I mean,
I can imagine.
And you can do lots and lots and lots of accelerated physical testing, which we did at some labs that the Federal Railroad Administration has, and you can do lots of finite element model analysis. You can do lots and lots and lots of things, but at the end of the day, it's a physical thing that's sitting out in a really remote location, getting beaten on all the time.
Yeah, and nobody's going to be inspecting it every day. I mean, how often are you inspecting those ties? Not probably that
often. Not as much. Annually at best. I think the railroads are working on some technology that'll allow sort of more continuous monitoring. Where you can
at least visual
put a device on a locomotive and have it constantly be getting data, but they're not quite there yet.
Yeah, I guess it would be compression type of thing, which could indicate a bunch of things, not only just the tie, but the foundation underneath it.
Yeah, you get a lot from vibration.
Yeah.
A lot from vibration and heat.
Yeah, it's very very interesting. So what kind of plastics are you guys using in it?
We use predominantly high density polyethylene with a little bit of polypropylene. We've got the big challenge in manufacturing a consistent product from recycled plastic is that there's a wide spec of recycled plastic.
Huge.
As Americans, single stream recycling is just another word for garbage. People just throw everything in that thing, and who knows, right? And so we've worked with dozens and dozens and dozens. We've probably talked to 100 suppliers. We've got 3 or 4 that meet our spec, mostly around melt flow, kind of cleanliness. You need all the wood and fines and all the stuff out of the plastic.
Yeah. The contamination
and moisture content. So we really focus on that. Supply chain quality is really important.
Well, it's very difficult. So you guys are, is it an extrusion method that you guys are using?
Yes.
Okay. So yeah, I mean, moisture content, et cetera, is highly important, and melt flow. But so you're not exclusively using like post-industrial or post-consumer. I would imagine whatever it is that works.
We love post-industrial because it's clean.
It's much more consistent quality.
Got really long polymer chains. It's only had one heat cycle that goes through it. You heat plastic up 3 or 4 times, and the polymer chains break down. It flows a lot more easily, but it doesn't. You get less. You get less. Contact between your glass fiber and your polymer chain. So
you're mixing it. Are you mixing it with glass fiber as well? You are. So is that glass fiber? So that's not something that you could, is that recycled glass fiber as well? I mean,
no, it's virgin.
So does it have to be virgin? Is there?
Yeah, it has to be virgin for a couple of reasons. One is you need a really consistent length over diameter. You gotta control L over D, and you have to control the binder. typically called a silane. That the binder, is what allows the individual piece of glass to kind of stick to the polymer. Which is why I kind of push back with, oh, it's a plastic. It's like, it's not plastic, it's composite. I mean, it's 1 + 1 = 3, because plastic without, it's like concrete without rebar,
Yeah, exactly. So it's kind of like steel reinforced. So it's glass reinforced plastic is basically what it is. So it's really, so you can't use like a recycled like glass. You couldn't use like wind turbine blades or anything like that.
No, not until they figure out a way to extract those. My sense is that those are kind of laid down in mats. It's probably a woven like a.
Gotcha.
To do that, they'd have to figure out a way to extract those individual pieces of fiber, so they end up individually.
Gotcha.
And that doesn't mean there might not be a use for that at some point, but
just the recycle process isn't there yet.
It's not there yet. And then, the more steps you add, the more expensive it gets. And, then at some point you're just like, well, just as good to use virgin.
Gotcha.
And, the fact of the matter is that, the railroads have an engineering problem. And the engineering problem is that they need something that's not wood, that's as strong and stiff as wood.
Yeah.
If we could get, the reason we use recycled plastic is that it's much, much cheaper than virgin. If we could figure out a way to do it with virgin, we would get completely consistent product, but it would be very, very, very expensive.
Wait, okay. Now this is one of the few times that I've heard that the recycled plastic is cheaper than the virgin.
It's cheaper than virgin. Yeah.
That's amazing. Is it the type of plastic that you're looking for that causes that makes that way?
No, I think it's the fact that how the form factor that we use our plastic is that, we don't use pellets, we use regrind.
So, okay, I got you. Yeah. So you don't have to process it right down all the way to a pellet.
It doesn't need.
You're not going through a compounder or any of that type of stuff.
Correct.
Gotcha. All right, that makes perfect sense.
Yeah. It's not going through a compounder. It's not turned into a pellet. We use regrind flake, which is much more affordable than virgin.
Yeah, it absolutely is, and especially if it's, well, yeah, it just is. And for people out there who are listening who don't into recycling all that much, is just you take a bottle of whatever it happens to be, or purge from an industrial complex, industrial manufacturing, rejected parts or whatever it is, and you just grind it. Yep. You're literally just sending it through a grinder. Like, you see the videos of a grinder that, eats up a car engine. You're basically just throwing plastic chunks that might be purge, which can look like almost like lava type of stuff, right? The chunks that come out, chip it up into small enough pieces, and that's all you need.
Yep.
Maybe a light wash to make sure there's.
We don't even wash it. That's a value added step that our.
Oh, that's fantastic. That is fantastic.
Yeah. Well, and we've got some things that we do to control melt flow, but it's all recycled plastic.
Yeah, that is that, and it's cheap. So is your tie cheaper than wood?
Not yet. It's got a.
Is it just scale that gets it there?
Yeah, I mean, I think we live in a world where tell me how much it weighs, I'll tell you how much it costs, and so I think there's two things that get us there. One is just sheer scale. If you're, I think no matter what happens, if you want to be the trusted low cost producer, you've got to work at scale, and you can never forget that your customer, despite the fact they have a problem, they've got a way to solve it. and they've got the infrastructure set up to solve it.
It's already there.
Yeah, it's already there. So, they need an alternative that fits inside their budget profile. So there's kind of two things to do. One is scale. You get better absorption. You get better leverage with your suppliers. You get your factory turned on. And the next is product development. So I think there's a number of things that we're going to be able to do with advanced materials and advanced manufacturing that are going to make this thing much more affordable. And I think the third thing you could do to get to scale would be to create some sort of financing or leasing mechanism that allows you to kind of fit inside the budget profiles until the future cost savings pays for the current program. The thing that you find with your railroad customers is that their cost of capital is so low that it's really, really hard to create any financing solution that would make sense to them.
Yeah, so the only other thing is then some sort of incentivized program through the government to adopt it,
or an incentivized program through the government. Yeah, that's exactly
right. Which right now is stressed, to say the least.
Yeah, I think there's a couple shots on goal there. I mean, there's a couple programs through the FRA, and I think with this, business-minded administration, if you can point to a total cost of ownership advantage that accrues to the user, accrues to the user, and gets an industry to scale and stimulates plastic recycling in the United States and prevents the cutting down of trees. Now, people are going to complain, the wood lobby this and this lobby that, but I think it's really hard to push back against. We need to keep putting more plastic in landfills. That's a great idea. Let's keep putting more plastic. That's a great idea. We got to keep the landfill.
Dig bigger holes.
We need to keep the landfill. We need to keep the landfill industry going strong.
Listen, that's a joke to me, but it's also a reality.
It is a reality.
There's a lobby out there trying to keep the landfills accepting as much garbage as possible.
Yeah, that's right.
They're against composting. They're against recycling. They're against that stuff because they get paid tipping fees.
No, that's right.
In order to put it in there.
And the same lobby exists for, sustainable forestry. We plant 3 trees for every one we cut down. It's like, that's true, but 3.
That's only sustainable for a certain number of decades, though, right?
3 30-year-old trees does not equal 1 90-year-old tree.
Yeah, no, it doesn't. It doesn't even come close. Yeah, you're right.
So, I mean, these are, and keep it in mind that, your customer, this customer will take the sustainability win, but it might, all things being equal, they buy sustainability over, but they're really solving a business problem. I mean, they're solving an engineering problem. And our job is to give them something that works and get it to fit inside their budget, and then remind them that, hey, this is a good idea because the business case closes, and you get this case for sustainability for free. The sustainability comes along with it.
There's also argument against the correction to, like you said, I mean, the carcinogen of creosote, right?
Yeah, and we don't flog that too much. It kind of speaks for itself.
Yeah,
I think the railroad does a tremendous job keeping their railroaders safe. I think that they. It's a pretty safe industry considering all that they do.
Gotcha.
I don't think anybody, you don't really need to be reminded of that.
Yeah, I got you. It's just, it's there. It's not a punch that needs to be pulled in order to make this. But is the, excuse me. So how's the adoption going of this? How's the proliferation of these tricks? Are you making good headway so far? Is there long interest?
So, one of the things that I think is a signal is last month we announced that we took on a strategic partner who made a significant minority equity investment in our company. And that company is Sumitomo Corporation. So Sumitomo is, one of the, handful of these um, incredible Japanese trading companies that work all over the world.
Mm-hmm.
They have a major presence in steel. So they provide railroad steel to Class 1 railroads and railroads all over the world.
Oh,
They
wow.
also own half of the only manufacturer of rail seats in North America. A rail seat is that, the rail sits like this and it's got to sit in like a seat, like a little crib. And so I think what Sumitomo sees, they see a new category being created. I think that, our customers have said, we've got enough wood. Wood's going to be a problem, and it's starting to be a problem. We believe we believe wood ties are a problem. So, what I would say is this adoption from this, or so this investment from Sumitomo signals a transition to a new category of railroad tie, which is this. There's 4 to 6 million wood ties that are failing in less than 12 years. Sumitomo brings the reputation, the manufacturing excellence, and the capital that allows a company like ours, which was founder funded. My wife and I founded the company, our capital, with we took on a limited number of investors for a minority stake after the company had already been going.
Mm-hmm.
So now we've got the staying power to drive the adoption, tell our customer we can be more competitive, not lose focus on manufacturing quality, robust up our supply chain, introduce new products. So I think we're at the inflection point, Mike. I think we're at the inflection point.
That is fantastic. That's great news. Partnering with that company. Let me ask you this: how much? Got a million questions still, but how much does one of the tracks weigh that you produce?
220 pounds are ties. Yeah.
It's a lot of plastics, man.
And that's the thing, right? It's a lot of plastic. I mean, it's
That's a
not like,
lot of plastic.
yeah, it's not like, we make a marker cap from recycled plastic. I mean, it's a lot of plastic.
No, you're locking in a ton. I mean, not a ton, obviously.
Well, every 10 ties.
Every 10 ties is a ton of plastics, right? Exactly. That's I mean, and that's a ton with two N's and an E, right?
Yeah, it's a lot of plastic. Yeah.
Not just a TON, a TONNE ton. That's amazing. So let me ask you. So, what is the significance or the impact? Are there impacts on international trade laws on the adoption of your plastics? Right. So, in other words, does Scope 3 and use of vendors, et cetera, figure into those that are moving product on the rail when they try and sell it to, say, Europe? And when Europe is looking at, okay, we want to know the green, your GHG emissions, your carbon footprint. We want to know your sustainability. We got all these laws outside the United States that say, okay, how sustainable are you? And we all know those are reaching further and further into your supply chains, right? So does a railroad utilizing these ties have the ability to say, look, your Scope 3 is even lower now because, look, diesel per mile or diesel per ton mile, I guess, is how they measure it, so good. But then there's carbon because we're not replacing the ties. Then there's sustainability because we're recycling content into our ties. Does that ever figure into it, or it hadn't gotten that deep yet.
Has not gotten that deep yet, but it's worth looking at. I mean, it's a piece of the value prop that we've never amplified. Is what happens when you're able to say, the metric of merit is called millions of gross tons.
Okay.
So if you'd say, hey, for every MGT, million gross tons, we've got this sort of benefit, because as we go from the rail bed up, the tie to the tie plate to the steel, the locomotive, that
right.
Every bit counts.
I mean, if you remove the tree, you're removing a certain capacity of carbon sequestration, right? And as that thing, as the wood decays, it's releasing that carbon back into it. And with the plastics, that's it'd be interesting to see what that model of people at EcoVadis or something like that would be the ones that you'd have to go to those engineers. And
that's interesting. One of the things that there's a whole association for wood ties that we're not allowed to belong to, called the Railway Tie Association, but composites aren't allowed to be in it. And they say, well, when you use a wood tie, you're actually sequestering carbon. And you're like, wait, what? Yeah, well, because it's made of carbon, but you cut down a lung, to stick it in the ground, and then to your point, as it rots, it releases carbon, and then
it's exactly right.
And then when it goes to landfill, it turns to carbon, and
it decomposes and causes methane and other NOx.
So it's a funny bit. And
it's bastardized math, is what it is, Tim. You know that.
It's a funny bit, and we've kind of said to our customers, and again, this is like the 10th piece of the value proposition, which is you're building a carbon mine that 30, 40, 50 years from now, someone is going to figure out what to do with these carbon molecules. Someone's going to figure it out.
Sure.
And so instead of going through and mining the landfills for plastic, you're going to have a carbon mine.
You absolutely are. And I mean, in reality, you're at the very precipice of starting a plastics mine. Really, I mean, you had right, because now you take all these, and maybe not. Maybe it's more of a circularity thing, because all you're doing is you're not all you're doing. It's very, very important what you're doing. In my humble opinion, is you're basically sequestering plastics.
That's right. Right. And that's what we say. We say we're that's exactly the term we use, that we're sequestering carbon. We're sequestering carbon until someone figures out what to do with it, because the circular economy, I mean, it sounds great, but if you have 100 pounds of plastic, it makes one round trip, there's 8 pounds left, makes another round trip, and there's 12 or 14 ounces left, and then it makes one more round trip, and there's nothing left. I mean, so two round trips of 100 pounds of plastic yields not a lot.
Oh, but that's a product or an inefficiency that's baked into the current circularity supply chains, right? I mean, if as we grow the efficiencies of the supply chains, doesn't that get better? That retention of volume get better? If it's just circular supply chains, right? I mean, because we're only recycling 8% of the plastics, right? And that's what you're
right. That's right. I mean, there's going to be, I would imagine what happens is that as the scarcity of recycled content, the scarcity, excuse me, the scarcity from a demand side goes down because more people want it.
Yeah.
What I get, what you'd want to see is more recycling capacity brought online.
Right. Exactly.
Which would create deeper behavior change in people to actually recycle stuff.
Yeah.
Which is going to be a signal to the virgin guys to bring more capacity online.
Right.
which drives down the price of virgin.
Yeah.
So if you're using recycled, you're like, yeah, I might as well use virgin. And the price for recycled collapses, and then people don't want to put capital in, right? So it's
a cycle that keeps going, and it perpetuates itself until, well, you've got to have those drivers to make that happen. And that's what a lot of the legislation are talked about, the extended producers responsibility acts and all those other kind of things were intended to try and do, is to try and somebody's got to break that cycle to
no, that's right. That's right. 100%.
And trying to make that happen. I love what you guys are doing, because once your ties, and you don't have a tie that's failed yet, but let's move forward 50, 60 years, 70, 100, 300 years, whatever it is. I guess if you leave the tie there long enough, it'll eventually decompose in 500, 600 years or 1,000 or whatever it is. We don't
10,000 years. Yeah,
10,000 years, and we probably won't be running around by rail by that time.
Yeah, I mean, yeah, so right.
It doesn't ever have to be really in a foreseeable future be recycled. But if you did have to recycle it because, let's say, something happens, there's a train wreck, and we got to replace these ties or whatever it happens to be, they can easily just be chipped up, melted down, and made into something else.
No, that's right. And there's going to be, there's going to be some number of our ties that fail because that's what things do, right? I mean,
right.
No, but you got to keep in mind that the railroad and its tie infrastructure is a redundant system. That's why they're placed, 20 some odd inches on the center for redundancy. So the question is, are you one of the things that happens with the composite tie is that if the ballast gets washed out and it gets in a fulcrum condition, our tie can break. Well, that's going to have you doing better ballast management. That you're going to shift, $100 of maintenance into $10 of maintenance to make sure that your ballast management is a little bit better, because you want to take care of these composite ties. And some of them are always going to break. And then you pull them out, and so one of our chief engineers that's on our team, he said, yeah, some percentage of your ties are going to break. Say it's 5%. 5% is less than 100%.
Yeah.
5%.
Last I checked,
5% is a lot less than 100%. And as you install them, you're going to figure out use cases where they don't work, and you're just like, doesn't work in that use case. But it's going to work in 95% of the use cases. It's going to work in a lot of use cases, and it just requires thoughtfulness and better engineering, and lots and lots of things.
That is really, really interesting. So when you're the content, and I'm all over the place because I just think of these questions as we're going, but the content of plastics that you're using, the post-industrial or post, PIR or PCR, whichever it happens to be, color doesn't matter, does it?
Color doesn't matter.
So right there, your methodology and what you're doing in a product you're building increases the ability to recycle just like that.
Yeah, it doesn't need to be sorted by color. A lot of what we get, say half, is already black, so it's got carbon black in it. We just add some carbon black and we make it all dark.
Yeah. So you add to keep it dark.
Yeah, to keep it dark.
Is there a reason for that other than that's just the way it is? Or?
Yeah, you just kind of a finished product. You want it to look a certain way, and then you want a little bit of the UV protection that comes from
the
carbon black.
Yeah, you don't want a yellow tie and a red tie and a green tie and a brown tie.
Yeah.
Although that would be pretty cool to have.
It could be. It could be cool.
Could be kind of freaky if you were anyway. It's kind of cool.
It could be.
It's kind of cool. So is there international demand or
there is,
and is there a difference between domestic and international at this time?
Yeah. The biggest difference is in profile. So, our profile is 7 by 9 inches by 8.5 feet. So some profiles are 6.5 by 8.5. So there's just different profiles.
because the rail is not the same in Europe, is it?
Yeah. The gauge will be different. They'll, so we're exploring. We know that there's a market, UK, Australia, Germany, South America, parts of Asia, and a great opportunity with our partner Sumitomo is that they've got channel access to all of these, customers. So we started exploring, whether it's by export or whether it's building local manufacturing. I think there's a big opportunity there. There's a company called Sekisui that is a Japanese chemical company that manufactures. It's a tie made from polyurethane that is not dense and very strong. So think of it as light and strong, but it's 4 or 5 times the price of our tie. So they've been successful using a specific standard called the Japanese International Standard to get this tie spec'd into specific high-speed rail opportunities.
Okay.
There's, it's kind of hard to see over, that's maybe like 2 mountain ranges away, and we're kind of scaling the mountain. But, our belief is that, with the abundance of recycled plastic, we should be making lots and lots and lots of things for industrial applications, affordable.
I would think so. I was just going to ask why, if you're going to run a locomotive train, over this stuff, it's a little bit of weight, so they're fairly strong.
They're very strong. Yeah.
So there's a bunch of different industrial applications for this besides just railroad ties, right?
Yeah, moorings, pierings, telephone poles, utility poles. A lot of that technology now is pultruded, which is kind of an expensive way. You kind of pull and wrap these things. It can be, kind of expensive. Our question is there another more basic way to build some of these structures?
Yeah.
Using, pultrusion is expensive, using more of an extruded approach.
Yeah.
But one of the things that we did, Mike, that I think, we're proud of, and is that, Startup 101 is that optionality kills startups. And a lot of times what happens when you're in a startup is that you got time and energy and capital. You get to the half-yard line, and that's where all the resistance is, at the half-yard line. You're like, oh, we've made all this progress. We're at the half-yard line, and you're like, well, let's do something else to see if we can get something else to go fast.
Yeah, get across that half-yard line.
And what happens is that one gets to the half-yard line. And so one of the things that we did that we're proud of is that, there's other lengths of ties. There's other, there's 10 by 10 inch ties. There's 4 by 6 inch ties. There's half ties. There's long ties. And we're like, we're not doing that. We're going to make an 8.5 to 10 foot tie that's 7 by 9 inches long. And we're going to not do optionality. And I looked at, it was one of the lessons learned from a handful of other companies that tried to do this. All of them entered other markets. And if you're extruding something, the tooling's really expensive. It's not like it's, you gotta pull the mold off. You gotta put the mold on. And so we said, we're not going to do that. And so we're just optimized to do the biggest, fattest part of the market, which is standard railroad ties.
Yeah, there you go, and stick to that. That's great. That is great advice. I was going to ask you what advice you might have for somebody that's looking to do something like you're doing right now.
Don't do it.
Besides, don't do it.
Any founder Any founder, when they get to where we are, it's like, don't do it. Yeah, I mean, I would say three things. One is you gotta solve a problem. Solve a problem. A lot of startups, they're like, oh, we have an opportunity, but you gotta sell a painkiller, not a vitamin. And a lot of startups get in the vitamin business, and you got to be in the painkiller business. And the second is you gotta have a strategy, meaning that it's better if it's a good strategy, but you got to have something to guide your thinking every day. You've got to, and we had one which was attack all the class ones, build relationships with the class ones. And if we couldn't convince them, we didn't try to convince them. We just went to the next one until we got adoption. And then the third is that, it's the team, and that's really rooted in, you got to care for your people, and not care about them, but care for them. And, in our business, our frontline manufacturing guys are, mostly formerly incarcerated guys. It's an unskilled labor job. We offer, living wage, 85% of their healthcare premiums, 401k match. We do all that stuff that, business can be and should be a force for good in society. And so we're kind of working at that friction point with that group of great teammates.
That's fantastic stuff. Tim, it's been a pleasure, my friend. I'm so glad that we're impressed. It really has. Thanks for coming in. Hey, dude, win the day, my friend.
Win the day. Vincere Diem. That's our saying for this year.
Vincere Diem. I know. I saw it on your shelf back there. I saw it up there. Your thing up there on your shelf. I went to Mercyhurst University in Erie, Pennsylvania. We were Carpe Diem.
There you go. That's right.
So Vincere Diem. I love it. Everybody else, hey man, Vincere Diem, my friends, and peace and love to everybody. Thanks for downloading and watching. And next time we'll see you guys around. Peace and love, everybody.
Bye-bye.